Okay, guys, so we can start today's session. So, yesterday we have been discussing about web modes, and we have seen some basics of web modes, how to create simulation using web modes, and how to interface web modes and ROS 2. So, we tried some examples yesterday, but there was some bugs in the web boards, not in the web boards, but web boards ROS interface basically. So what I did was the bugs actually were in the packages. So if you just check the Synaptic Package Manager, and if you search for web boards, you can able to see the ROS web boards packages. Okay, so these packages are available as binary, and also the packages are available as source code. So the official repository of webboards ROS 2 interface is here. So basically the webboards ROS 2 interface will work webboards like Gazebo. So you know what is Gazebo and ROS 2 interface doing, right? So basically using the URDF spawner, you can able to convert the URDF into the SDF format, which is supported by the Gazebo. Okay, so similar to that in webboards, there is a robot model that we can spawn from the URDF. Okay, so the webboards ROS 2 interface includes like driver, which is like connecting webboards and ROS 2, and it is like pushing the URDF or spawning the URDF into webboards. And also there are some examples that they have given, like with the turtle board, universal robot, then Tesla. All these things are there to test your I mean the setup is correct or not. Okay, so I actually discussed about webboards yesterday. I'm just giving an idea. Webboards is it's basically a robotic simulator, and it was predominantly used in education, mainly in institutions, and it was actually a proprietary software till 2019. After that, they open sourced the simulator, and they have created ROS interface, all this stuff. Okay. So why we have to use webboards? So webboards, I can show you the GUI again, like if you forget. So this is the GUI, and maybe I can load a sample simulation. So there are tons of samples actually. So you can load any robots. Most of the robots are there. Maybe I can load Tiago. And these all are, I mean, existing examples, and you can load it and you can play with the simulation. The GUI is user friendly. There is no difficulty in starting working with webboards, and also the tutorials are also very good. So this is an example of the simulation of Tiago, and so the programming in webboards, like you can do here on the right side, there is a text editor, and you can write the programming on the right side, and it will be loading like a controller. So basically the right side thing is a controller. You can do from the GUI itself, or you can write a external controller as well. Okay, so it is like waving the hand, and also we can see the depth camera inputs, I mean outputs. Here is the RGB camera and this is the depth. Okay, and yeah, it is like I think it's rotating its head, and yeah, so this is what it will look like. And I think we can also move it. It seems like you can drive the robot by selecting the 3D window and pressing the keyboard. Yeah, I think it's moving. Okay, so you can see the rendering is not that good. That is not because of the simulator. It is because of the graphics, because I'm working from a VirtualBox or VMware, so the simulation driver is not that good. Okay, so it is mainly using for the education purpose, but you can also use in any application. Okay, there is no I mean restriction in using. Okay, so what we are doing is we are going to see some of the examples, that is WebBoards and ROS2 examples. So let's see how it works. Okay, so if you want to work with WebBoards, I will suggest you to clone this. Okay, and start working on it, or I will share a link to get started. Just simply clone it and then you can do the call count build. Okay, I think the instruction will be here. Let me see the installation instruction. Okay, anyway, fine. So let me see the interface is working. These interface basically ROS2 packages. So I'm just trying to load an example. So what I'm doing is I'm running a launch file. Okay, and like Gazebo, the WebBoards will be popping up, and it will be loading all other things like ROS2 control. Then all it will be spawning the URDF into WebBoards. Okay, so here you can see an application. One second. So like one robot is putting the can there and another robot is taking the can. So the working will not be perfect because of the graphics issue and all. It will not be perfect, but it's basically doing using ROS. Okay, so this kind of application that you can do easily with WebBoards. Okay, so I'm just closing it, and I'm planning to show you some more example. So the example were not working last time because of the bugs in ROS2 control. So here there is an example for Turtleboard 3 simulation and also the navigation. Okay, so I will show you the demo, and then I will be taking that launch file, like what are the things that we need to do in order to spawn the URDF into WebBoards, and what are the WebBoard specific things that we have to do in the launch file. So here you can see the Turtleboard 3 burger URDF. It's actually spawned into WebBoards, and I'm starting the keyboard teleop. So one second. I'm starting it. You can see like we do the teleoperation You can see the examples here. It's all there. Maybe I can share the link. Yeah, so I think Kasim actually put a comment, right? Visualization seems much better in webboards. Yeah, that is correct, Kasim. So the visualization that you are seeing here, um, it is much better if you are working from a GPU based PC. If you have NVIDIA or something, it is much better. But currently, if you can check the rendering, like in the help. If you check the OpenGL information, you can see the OpenGL. I mean the driver that we are working is basically the VMware. You can see here the VMware stuff. Okay, so it is not that great. Okay, so we have seen the demo like of Turtleboard, which is working on webboards, and we can do the teleoperation. Okay, and so if you can do this, what about what about the navigation? You can also do that. Okay, so the comment is why we will mostly use the Gazebo, why robotics prefer Gazebo. That's actually a good question. So the reason is that Gazebo is the free simulator that comes with ROS. Okay, Gazebo is the simulator that comes with ROS, and it's free, and there is a tight integration with ROS and Gazebo. Okay, but the web boards actually went open source in 2019. Okay, 2019. Gazebo is there from 2007. Okay, so that is the reason there was no availability of the free simulators. So that's why people selected Gazebo over the web boards. Web boards, I mentioned, right? It was proprietary at that time. So that was the reason. Okay. But nowadays, like, we have better simulators, and it's our choice to choose what simulator that we want. So we have a better simulator, obviously we have, and you can see the laser scan coming from the web boards. Okay, so if I am just moving around, you can see the laser scan. Okay, so web boards is publishing ROS topics like Gazebo. Okay, you can easily see, right? Okay, and what about a navigation demo? Okay, it's already there, so I'm not doing anything. I'm just simply following the tutorial that they mentioned. So here they have mentioned how to do the slam and how to do the navigation. Okay, so already the navigation is ready. I mean the package navigation is already ready with a existing map of this world. Okay, so you can simply try it, this command, that's it. So it will be loading the map and you can do the navigation. So let me try that. Okay, it is loading the Turtleboard and the navigation stack. Okay, and it will be starting Arvis. Okay, so seems like it's all started and the map will come, but if that is not happening, maybe we have to restart. 1 second. Again, there are bugs. Maybe what I will do is I will be restarting it. 1 second. Okay. Okay, the RVC is here. Okay, now it started. You can see the navigation stack too, and you can simply give the goal position. You can see the robot is moving in the simulation. You can put some obstacles over here. One second. Yeah, maybe not. We can first try this. The localization is having some problem. One can be the CPU resource, because I'm working from the VMware, so there is limitation. You can see here, this is the navigation to RV's plugin, which is like it is showing navigation is active, localization is active, and feedback we are also getting, and we are also getting the estimated time to reach the destination, and also the distance remaining, time taken, recoveries. All this information is there for the new navigation. So we will be seeing the navigation from the next class. Okay. And okay. Yes. Okay, so that is the navigation demo that we can work on. So if you set up the web boards, what you can do is you can try the example that I have given, the link, and initially if it is not working, just restart it and then try again, it will work. Okay, so now I just want to show you how these things work. Okay, that we need to know, right? Like, what are the things happening when you start the launch file? So I'm planning to take the Turtleboard. Okay, so this is the Turtleboard demo package. Okay, so basically, in order to create a webboards ROS interface, okay, there are some official tutorial that I can give you. This webboards ROS 2, if you check it, there is an official tutorial is there in the ROS wiki. Okay, so they are talking about like how to create a package and include the controller and the launch file, all these things. Okay, so this is for this in this example they are using the EPUB. So they are like discussing how to add the EPUB and add the controller and all this stuff. Okay, so in the Turtleboard example, you can see this is the package that they have created based on the instruction. So this is the launch file that we are starting. We can see each and everything. On the resource folder, we can see okay, Kasim, there is a webboard based ROS. Okay, that is great. Like 1 second. So Kasim actually shared a course. Yeah. So it seems like okay, that is great. So if you want to know more about so basically I think it is teaching the robotics core concept using the simulator. Okay, so this is good. Okay, and yeah, so coming back, so we can see in the resource like You can see the URDF, which is to be spawned, and this is the map saved. This is for the nav2 parameter. So in nav2, the entire parameters are in a single file. Sorry. So you can see, anyway, we will discuss more about nav2 in the upcoming class. So like if you want to store the AMCL parameter is here, then BT navigator, which is a main node which is communicating to the controllers and all the other subsystems, and you can see the controller, server, local cost map, global cost map, then map server, map saver, all the configurations are here. Okay, and recovery server, all these things are here. Then map server, all these parameters, and yeah, I think, and also the ROS2 control. What are the controllers, ROS2 controller that we are using here? Differential drive controller and joint state controller. Like the ROS1, if you remember, in order to move the differential drive robot, we need the differential drive controller and the joint state controller. There is a test here, and this is, they are showing a plugin, it's actually for, I mean, interacting with the web boards externally. That is for example, and this is the world file. Okay, this is the world file that I'm talking about for web boards. This is the WBT. Okay, so we know the world file of Gazebo, right? Gazebo.world file. So in web boards, this is .wbt. I think last class we have seen that, and so you can see all these things. So what are the things happening now? Okay, we can check the launch file. That is the important stuff. So here on the folder, we have the world file, we have the the URDF, we have the controller configuration, navigation configuration, map configuration, everything is there. Okay, and in the launch file, you can quickly go through it. It's not that difficult. Like, we need a robot state publisher, obviously, because the joint state controller is giving the joint state topic, and robot state publisher will be publishing the TF. Okay, and there are some static TF that we need to publish, base link to base footprint. It may be for the navigation stack, and there is a controller manager. I mean, in order to work with the differential drive, if you remember the ROS1, we started the controllers, right? Differential drive. So this is what the controller starts, and this is the URDF. Okay, URDF path, and this is the ROS2 control configuration, and there are some topic mapping here, and yeah, this is the web boards controller. It seems that we need to check, because the web boards controller is basically starting web boards with the with the URDF. Okay, with the URDF, and these things are for the navigation. Okay, it's already there. It seems like they have actually given the blocks. So this is for the ROS controller, and this is for the web boards control, basically. So it will be starting the web boards. It seems that we will be seeing that. This is for the navigation. So for the navigation, what we need the navigation launch file, right? So here what they did was, they are reusing the launch file of the Turtleboard 3 navigation. Okay, or basically the Turtleboard 3 stack is already having the navigation package. Okay, so they are simply running that launch file. They are not creating a new navigation launch file. They are using the existing one. and these are the map file. It is already there, and this is the navigation parameter. So it's all straightforward. And if you are using SLAM, if you want to start the SLAM, then it will be starting cartographer.launch from the Turtleboard 3 cartographer, which is already installed on our machine. Okay, and then there are some nodes to wait for the simulation to be ready. Okay, yeah, so these are the things. So basically this is the webboards controller is what starting the webboards and connecting to the ROS2 controllers. Okay, sorry. Okay, and this is the world file, webboards world file, which is should be, I think it is using for, let me see where is the world file is using. Okay, yeah, it's in the webboards launcher. So I think I made a mistake in the description. So the webboards launcher is starting the webboards with the world file. Okay, and the webboards controller is actually starting the simulation and pushing the model into the webboards. Okay, so this is where the webboards is starting. So if you want to start the webboards in the simulation, I mean in the launch file, you can use webboards launcher. So you may be thinking these kind of things that are not seeing in a launch file, but on the top you can see actually the webboards driver, the ROS2 driver is having all these things. Okay, so we need to import all these things. Previously we will be using we are using the launch module and putting all this stuff, but for launching webboards we need to import these webboards packages, okay, and its class modules. Okay, so that's how we are launching webboards with a world file. And like the gazebo, like we are starting robot state, TF2, then the ROS controls, then navigation, SLAM. Yeah, that's it. Okay, so I know it is like, I mean it will take time to like describe each line, but from my understanding or my experience, just understand each blocks, that is better. Like if you want to work on I mean if you want to fine-tune something, then you can look closely. Okay, so that is what I am doing. So this is what the robot launch file looks like. Okay, I hope you got some idea. You can also check other robots launch file. So this is the multi-robot example. It is starting the controllers, then yeah, I think it is having two description. Yeah, it is having the UR5 with gripper and the ABB model. So you can have you can explore these examples. Okay, it will be good if we can I mean if you are planning to do some simulation with webboards, then it will definitely help these examples. Okay, so I just want to know, like, if you have any doubts in the webboards simulation with ROS. We will be discussing some example, and mainly the launch file is the main stuff. I think you know that. Do you have any question? Maybe you can either comment or you can ask. If not, we can jump into the next part, which is Isaac Sim. Okay, I'm just closing everything. Let me start the Isaac stuff. So let me know if you have any questions. I'm just sharing the Isaac Sim link. Okay. So Kasim having a comment. Thank you for the explanation. No question. Okay, okay, good to go. So next is the Isaac sim, which is, I will say, it is going to be the future of simulation. Okay. Before starting with this, I have to say that in order to run Isaac sim, there are some system prerequisites. Okay. So if you're not meeting that, then you can't able to run the simulation. Okay. So in my PC also I can't able to run it because I'm running on NVIDIA 1050, which is pretty old, but I can run rest of the simulation. I mean, Gazebo, all this stuff will be working cool, but these NVIDIA simulator requires more GPU. Okay, but I'm not against it because with that requirement, they are delivering realistic simulation, which is actually missing in Gazebo. Okay, so I mentioned this will be going to be the future because Nvidia is heavily investing in Isaac Sim to pioneer the simulation domain. Okay, especially the robotic simulation. Okay, so maybe I can show you some videos of the Isaac Sim, then you can decide it is good or bad. Okay, after that we can start discussing about what are the things, how to install it, and what are the core concept and how to interface with ROS. Okay, so let me take Isaac Sim. Okay, so it seems like this is one video they have released in CES. Let me increase the, hope you can see it. So all these things that you are seeing is the Isaac Sim. Okay, the simulation is realistic, and also there are a lot of things that we can do. See, you have seen this, right? Okay, so this is navigation stack, and there are some advanced research going on in the AMR using Isaac Sim. So on the right side, it is the simulation, and left side it is physical model. So how realistic is the simulation? Okay, so that is what you can able to see. So this is simulating some other scenario, not only the robotics. So this is like a robot, yeah, in the Amazon robotics, and what you are seeing is in the simulation. Okay, and you can simulate lot of things. This is from QUT, and this is from ETH Zurich, and yeah. So yes, so I think now you can decide, right? Like, see, you can simply see this demo. How good is the simulation? How good it is the simulation? So this is a digital twin. Like what we are seeing is the I mean the simulation and also the hardware working. So that is what I'm saying. The Isaac Sim is seem to be the future of simulations, so especially the robotic simulation. Okay, maybe we can get started with that, so you will get an idea. Okay, so I hope you have taken the link that I have shared, right? And I can share one more link. Okay, I'm not sure you have you had a look on to these things before. Okay, yes, 1 second. Okay, maybe we can start discussing iSuccess. So unfortunately, I can't able to show you the iSuccess in reality. I can show you the simulator, but it will not work. Okay, I have installed it. You can install iSuccess in Windows, Linux. I think, yeah, both Windows and Linux. So here is I have installed iSuccess on Windows. It will not work, but we can at least see the oh, I think I need to enter the email ID. Let me see. 1 second. Let me log in. It seems like the email ID. 1 second. Let me try to like start the iSuccess for you. Basically, it can you can see the iSuccess, but because of the CUDA version, it will not work. Okay. Okay, security code. 1 second. NVIDIA's. Okay. Okay, I think I have logged in. So Exchange. Okay, let it load. It will take some time, and the size of this is around 9 GB or something. Yes. Okay. Yes, iSuccess launching. So there are different mode of starting. I'm just starting the iSuccess itself, so you can able to see the message. Actually, it's trying to load, but there are some error in between. Maybe I can show you that. Mainly CUDA related, so it will be saying like it requires some version of CUDA, but basically that is not there in my PC. Okay, so let it load. It will take some time. Yeah, so basically if you have a powerful computer, and if you have these following system requirement, it will be working. Okay, I'm not sure how many of you having this. So you can comment if you have this system requirement. Okay, so at least you need to have CPU. I think it's fine. Okay, CPU like in Core i7 7th generation. Okay, and 4 core and RAM 32 gigs. 60 gigs is what I have in my PC. And okay, I think in Kasim, I think you have the 3070, right? It's good. So it is actually good to go. So the minimum thing is 2070 with VRAM. Video RAM is 8 GB, and if you want to simulate like in a good I mean, if you want to simulate some high-end thing, I think 3080, or 4050. Okay, so you may have heard about in the not AMD, NVIDIA GPU, right? So this is like the latest, the 4050 series. 4 series is like mostly the latest. So if you have a laptop that you have bought before 2-3 years, then I think it's good to go. So this is a basic PC requirement. So if Kasim is having this stuff, you can simply install it and make sure you have all this. I think you will have the AMD Ryzen 7 or i7, it will have, and the RAM you can check. Okay, 64 gigs is that they are saying, but I think 32 gigs is also fine. Okay, 32 gigs with i7 and this GPU is what important. Okay, so this is what the Isaac Sim looks like, but it will not work anyway. It is like it is showing RTX loading. There are some utilities examples here, but it is not going to work. Okay, so let me give you a short idea about Isaac Sim. Okay, then we can see some video examples. Okay, so Isaac Sim it's a robotic simulator which is built on NVIDIA Omniverse Kit. Omniverse Kit literally is like a toolkit or SDK which is providing a set of things like the Omniverse Kit can is having like publishing, subscribing kind of environment. Basically, it is like a toolkit from the NVIDIA, and it is having a lot of components. Okay, so Isaac Sim is built on that that toolkit. Okay, and this Omniverse Kit is giving like the NVIDIA is working on the GPU stuff, right? So the Omniverse Kit is designed for this kind of 3D application. Okay, you can create the 3D model, you can render it. So all these things can be done by Omniverse Kit. And in Isaac Sim is using the capabilities of Omniverse, and then it can simulate anything, like mainly robotics they are focusing, but you can simulate anything. Okay, so in ROS Gazebo that we are using URD of mainly, right? So in Isaac Sim they are using USD. Okay, USD, I'm not sure you heard about USD. It is called Universal Scene Description. Okay, if you simply search for USD, I think I think there are some links here. So this is a main format that they are using. Okay, NVIDIA is using. So why they are focusing on USD? Because there is a reason. I'm sure that you heard about the Pixar movie. Like they are very realistic, right? So the USD is actually created by Pixar. Okay, and you can see some example of USD. Okay, so this is a cinematic teaser. Okay, that is using Omniverse. Okay, so you can see how good it is. Okay, it's basically a simulation that is created using Isaac Sim, it seems. Okay. Okay, so let's see how it is. Okay, so if you are using NVIDIA stuff, I think they are giving importance to the realistic graphics, right? So they are the pioneers in that. So that's what we are getting from Isaac Sim and the Omniverse. Okay, so these kind of motion, and I mean it's actually simulating basically. They can it's like a game, right? So you can actually create robotic simulation like a game. that much of realistic environment that you can create. Okay, so that's why they are recommending this much of expensive graphics card, because if you want to play a high-end game, obviously you need a better GPU, right? So that's why they are recommending it, and you can see how good it is. Okay, yes, I'm just pausing it. So USD is what using by iSUGSIM, okay, or the Omniverse they are using USD. So they but the good thing is that you can import any kind of robot models or any kind of machine model into iSUGSIM. They have lot of extension. So if you're working with Chrome, we have extensions, right? Or like plugins, right? So like that, they have lot of extension. So if you have the URDF of your robot, you can simply import into iSUGSIM, okay? And if you want to communicate with ROS, they have a ROS bridge, okay? So it will be working like Gazebo, okay? Gazebo and WebBots, okay? And one of the other use case of iSUGSIM is that we already know, like, the iSUGSIM is giving realistic data, right? So it can be used for collecting data set, which is very, very important for AI. Okay, like if you want to train a model, if you want to train a object detection, Gazebo will not give you a realistic data set, that is for sure, right? But iSUGSIM can give. So that is what they are saying, like you can create synthetic data, okay? And you have seen the OpenAI Sora, right? That is released by OpenAI. I mean, they released late, I think 2 days or before. So they are creating like this video thumbnail that you can see, right? So these all AI generated video. Okay, so in order to do that, in order to train that kind of model, I will say this kind of simulator will be helpful for creating the data set. Okay, so the iSUGSIM basically is a product of NVIDIA, which can be which can be used for robotic simulator or any physics simulation, and it is having a lot of stuff, like you can add the capabilities by writing extension. Okay, so you can import URDF, you can do the navigation. There is an occupancy map creation, like if you have a simulated world, instantly you can create the occupancy map or the 2D map of the world for the navigation. So you don't need to do the mapping, you can simply create the map using occupancy map extension. Okay, so this is what the iSUGSIM looks like. And you can interact with it. You can interact with iSUGSIM using ROS, or you can interact with the UI. If you check the UI, there are a lot of options, and there are a lot of GUI components available. I'm just closing it. So you can interact with it using UI, and you can also create extensions using Python API, and you can also directly interact with iSUGSIM. Okay, so these are the ways to interact with iSUGSIM. Okay, so obviously we are going with ROS. Okay, that is what we are focusing on, and they are giving the explanation of each thing. It will take time to read all this stuff. Okay, yes. So we are interested in the ROS part, so I'm jumping into the ROS part mainly, and let me see if I can give an idea about iSUGSIM interface. So I will say the iSUGSIM interface, this is a GUI interface, right? You can see the video. They have a good tutorial, and they are explaining about the GUI that we have just seen, and you can add the components on the viewport, like the Gazebo that we have already seen. And you can start the extension. For example, I can show you an example for the URDF importing. Okay, so it's like the GUI. It's a user-friendly GUI, and you can do the stuff like maybe I can show you the URDF importing, so you will get an idea. So we have the extension for URDF importing. So just start that. So currently the video is showing like it is just opening a USD file that is already there for a room. Okay, and so this is a USD file for the room, and then they are starting the extension. On the top you can see ISAC util, from that workflow and URDF importer. Okay, and then you can just input the file. Okay, if it is a Turtlebot, you can simply browse that URDF, and then you can also give the output folder. So I think it will be importing to USD, I guess. Okay, so here we have imported the so you can design the robot model in URDF, and then you can import to the ISAC sim. Okay, and then you can connect the ISAC sim to ROS, and like other simulator, you can implement the navigation, manipulation, all the stuff. Okay, yes. So if you go to the rows section, you can see the first section is like obviously importing the URDF. Next section is like how to run the robot in ISAC sim. So if you import, or if you want to simulate a robot, we have the model ready, then how to work with it. Okay, so that's where ISAC sim actually bringing a visual scripting. Okay, so I just want to show you this image. So like if you are working with ROS, we have to like code it in Python or C++, right? But like if you want to work in ISAC sim, they have a visual scripting format. Okay, visual scripting. So it is good for basic stuff. Okay, this is enough, and all these blocks that you can create actually using Python script, or like writing extensions, or these things can be created. These blocks can be created. So if you check this visual script, maybe I can quickly explain it. So on the left side, this is kind of a tick. A tick means you can read the title on playback tick. Okay, what it is doing is it's simply generating some ticks in order to trigger the blocks. Okay, so the tick is connected to the articulation control and going to the rows to subscribe to. So this visual script, or it is specifically calling action graph. Okay, so this action graph, what it does is that from rows you can publish the command velocity. Okay, so this visual script or action graph will be subscribing to that command velocity and run the Turtlebot. Okay, run the joins of the Turtlebot. Okay, we have a differential drive controller that we have in the Gazebo. So you can see here there is on playback tick. Okay, so this will be keep on executing. This is like a loop kind of stuff. In order to keep on executing it, you can use the on playback tick, and so the rows to subscribe to will be always listening. Okay, it is always working, and whenever okay, so this block is for subscribing. From the name itself you can see, and in order to do the rows to connection with ISAC, we have another block called rows to context. So in that you can mention the domain ID, like if you are working from another network, you can mention the domain ID and all. and this is for the subscribe twist. Okay, you can actually configure this block. You can I think change the topic name and all. Okay, and when the subscribe twist got some topics, it will be triggering the differential drive controller. Obviously, like when we get the command velocity, it should be going to the differential controller, which will be converting into wheel velocity. Okay, wheel velocity. So here when we get the rows to topic, it will be triggering the differential controller, and the differential controller it's actually like, you can see the output from the subscribe twist block is like vector. Okay, but for the differential controller we need to break down this vector into three parts. Basically the angular velocity is xyz, linear velocity is xyz. Okay, it will have three components. So the angular velocity is got breaked up, and then the c value is only we require. Okay, angular rotation. And from the linear velocity we are scaling it for the, I think this scale to from this is for making compatible with the Isaac sim, and like a conversion of value, and then again breaking the vector and taking only the x value. Okay, x and z value that we are taking, and it is feeding to the differential drive controller, and it is creating the velocity command, and the velocity command going to the articulation controller, which is basically the controller which is moving the joints. Okay, moving the joints. And this is the list of joints names. So here you can see there are two joints, which is left and right joint, wheel joint, and which is making an array and feeding us the joint names. Okay, so this is called the action graph. So using NVIDIA Isaac Sim, you can create this action graph, and you can simply press the play button, and this action graph will get executed. So here in this example, you can see for the twist message, basically you can publish from the row side, and you can control the robot from the teleo. Okay, so basically you can interface a robot in Isaac Sim from rows. That is what we are saying about. Okay, so if that is the case, we will get everything. Like you can publish camera images. So this is an example for like publishing or getting the camera images from Isaac to the rows environment, so you can visualize in RVs or RQT. Okay, and here they are simulating the LiDAR. Again, similar thing, we have a action graph, which is I mean keep on updating the LiDAR. Okay, so these all are row specific blocks. You can see here rows to RTX LiDAR. So the output will be a rows topic. Okay, so after this, after running this, you can see the output like this. Okay, for the LiDAR. Okay, LiDAR and image, all these things. Okay, so basically using the action graph, we can able to communicate between rows 2 and Isaac Sim, and even we can implement the navigation stack, because we will get all the things like odometry, all these things we will get. So here you can see a 2D map, right? So the main reason why we are doing the SLAM is to create the 2D map like this, right? But if you are working with NVIDIA Isaac Sim, you can directly create this map without having without doing a mapping. Okay, and you can interface to the navigation stack. I'm just showing a video. So it will be working like the web boards. So you can see on the left side the robot, the Cartier, Carter. That is the name of the NVIDIA robot for the demonstration purpose. So here they are giving a goal position. Maybe I can, yeah. and you can see the image. Yeah, the robot is doing the navigation. Okay, so that is the nav2, and they also interface the move it. So if you want to interface this, like from move it, if you want to do the interfacing, you can able to do it using the thing. So here they have just showing the gripper movement. Okay, and this is, I think, the movement basically. So you may be thinking on the left side it is actual robot. No, it's not actual robot, it is Isaac Sim. So it is very close to the real robot, right? It's very close to the real robot. So that's what I'm saying. We will get the realistic rendering. Yeah. So when we press the plan and execute, it is moving to that. Okay. So for that, like in order to work with the move it is, I mean, you can use this. So like that, there are multiple interfaces to the Isaac Sim. Okay. So you don't need to create something. The everything can be done inside the Isaac Sim, and you can run the ROS2 navigation stack from that. Okay, because you are getting all these topics. So ROS2 navigation stack is only caring about the topics, right? If the Isaac Sim is giving all these topics, then it's ready to go. Okay. Okay, so I'm taking 10 more minutes to introduce another stuff. The same thing. So currently, like, we are talking about the Isaac Sim, right? There is another thing called Isaac ROS. Okay, Isaac ROS. So I just want to introduce that. So this is the stuff. Documentation. Yes, I'm just sharing the link. So what is Isaac ROS? Okay, so Isaac ROS is actually a different stuff. Okay, different stuff in the sense Isaac Sim is completely simulation, right? It's giving the simulated values and all. But Isaac ROS is kind of an accelerated stack. What is an accelerated stack? For example, if you want to get like high performance in working with ROS, then that's where the Isaac Sim comes. Okay, maybe I can show you some stuff. For example, if you want to do some object detection, okay, if you want to do some object detection, or some kind of acceleration in the sense, like, you know, if you are sending an image, okay, image through a topic, there is a latency. Okay, and if you are sending something, some kind of like point cloud or image, all this stuff, it will take some CPU computation. Okay, but that is where the Isaac ROS comes. It is actually like accelerated I mean stack, meaning you can stream the stream means you can send the topics. It is, maybe it can be a point cloud or image, and it is processing by the GPU, and the entire latency can be reduced. Okay, so the accelerated stacks are basically called nitros. So the nitros help us to bridge between ROS 1 and ROS 2. So if we want to bridge a topic from ROS 1 to ROS 2, if you are using Isaac Nitro stack, it will be much faster. And also if you want to add some kind of object detection, you can add the Isaac-ROS packages, because Isaac-ROS is a set of packages which is giving you accelerated performance using GPU. So these are the list of packages available to use, like you can ready to use. So these kind of packages like NVBlocks, there is a description already there, like CUDA accelerated April tag detection, then what useful stuff, yeah, deep learned stereo disparity estimation, then image pipeline. This is a useful stuff. Hardware accelerated ROS2 package for camera image processing. Okay, so like you can stream, like for one camera it may be okay, but if you are working with multiple camera, this kind of acceleration will definitely boost the performance. Okay. And occupancy grid localizer, yeah, this is again a very useful thing. I have actually used it in some application. Actually it was a demo. I visited NVIDIA headquarters last time, and they have actually showed the demo, okay, of this. So this is like a localizer. I'm not sure you work with AMCL. So when you start working with AMCL, mostly you have to give an initial pose estimation. Okay, in ROS2 they have solved mostly, but again, like we have to give the 2D pose estimate mostly. But the map localization package will be helping us to give a global localization instantly. You don't need to give the initial pose estimate. It can find it. It can find the localization itself. Okay, so and there is Nitros, which is like hardware acceleration for some messages, mainly image messages, and there is a bridge for bridging the ROS1 messages. So all these things is saying the Isaac-ROS. Okay, so you can have a look onto it. Again, if you want to work with Isaac-ROS, there is a system requirement. So if you're working with like PC, then NVIDIA GPU, you should have an NVIDIA GPU and you can work with it. If you're working with Jetson, you should have Jetson Orin or Jetson Xavier. Okay, so if you have NVIDIA GPU, I think it will work. Okay, so you can have a look on these things. Okay, and they have an extensive tutorial. It's very simple. That's why I'm not discussing it, because it's already there. The package is already there. Just download it and setting up. That's it. Okay, so it is like cloning a package, build it, and then run it. Okay, so that is the NVIDIA Isaac-ROS. So just go through this. It will be helpful if you want to put some accelerated stack on your robot. This will be helpful. Okay, that's it, guys, for today. Yes, so if you have any question, let me know. Okay, using Isaac-ROS, you can even write the CUDA ROS node with Nitro, so it will be accelerated. Okay, the normal, it will be performing much better than the normal ROS nodes. Okay, so let me know if you have any question, guys. Otherwise we can conclude, and next week we will be coming up with ROS2 navigation and manipulation. Okay, so let me know if you have any question. Any questions? Okay, so if you don't have any question, we can conclude for today. Okay, thank you for attending. See you next week. I will be updating the video soon. Okay. Thank you, everyone. Thank you. Thank you.
Thank you, sir.